Good evening. Today we are going to discuss some problems under multiple integrals. Some problems under multiple integrals. Okay. So first thing is you have to know what is mean by integral, and second thing is you have to know some formulas, some formulae under integration of single variables. Okay, that is single independent variables. Okay, so formula under integration, then only you will be able to come to the topic multiple integrals. Okay, then only able to come to multiple integrals. So in multiple integrals we will consider a function with two limits. Suppose if I am taking a double integral, okay, suppose if I am taking a double integral over the region R. So see here, this is my x and this is my y. I am having some region here and this is R. I am having some region here and this is R, means then I can evaluate the region. Okay, I can evaluate the area of the region by using two different kinds of integration. That is by means of two successive integrations. Suppose if A, I mean, that is if area is denoted by, if A is described as f1 of x, okay, f1 of x less than or equal to y, less than or equal to f2 of x. Okay, if I am having like this, okay, so y equal to f of x and that f of x lies between f1 of x and f2 of x, means then it can be written as, y1 less than or equal to y less than or equal to y2. Okay, this can be written as y1 less than or equal to y less than or equal to y2. In the same way, if I am able to write x as the function of y, means then I can write I can write it as x1, okay, less than or equal to x less than or equal to x2. Okay, in any way we can write. Okay, so this is one thing. The second thing is, if I am able to write in such a way like this, means then I am able to find my integration. My integration will be given by double integral of what is our function. A function will be a function of two variables. Okay, so f of x comma y into, here I can write dy, means I have to integrate the entire function first with respect to y, whose limit lies between y1 to y2. Okay, and then I have to integrate with respect to x, so whose limit lies between x1 to x2. So you have to remember always that your first preference should be given to the inner part of integration, then only to the outer part of integration, so that you have to remember always. Okay, so by this idea we are having three types of integration, that is double integration, three types of double integration. So let me tell you examples clearly. So first type, in type 1 we are having the same thing, I equal to integral, and one second integral, the this is called first integral. Okay, so f of x comma y, the limits of first integral will be of y1 and y2 when we are integrating with respect to y. So you will have here y1 and here y2. After that you have to integrate with respect to x. So here you will have x1 and x2. Okay, or you can change this as f of x comma y into dx dy. Then the entire function should be integrated with respect to x between the limits x1 to x2 and after that y1 to y2. Okay, so here you have to, here the function is of two variables. Okay, so when integrating with respect to y, you have to treat the variables in x as constant. Okay, you should not treat the variables x as variables. Okay, it should be treated as constant. Here x act as constant. Okay, when we first integrate with respect to x means you have to treat y as constant. You have to treat y as constant. Okay, so that you have to remember. So we can see all these things in detail when we are discussing about their particular types from the problems. Okay, so this is our I. Second thing is again I'm having two things. So this is one idea. Here you may have the both variables. Here both x1 x2 y1 y2 may be variables, because maybe variables. Okay, so you have to act accordingly. Okay, that you have to remember. Okay, then second thing is, if I am having the second thing, so if I am having in type 2, this is my I. Okay, this is my I. So I equal to double integral f of x comma y dy and dx means, and if suppose x1 and x2. Okay, and if suppose x1 and x2, so I am writing x1 and x2 in the place like here. If I am writing x1 and x2, okay, if I am writing x1 and x2 here, and y1 and y2 here, and if suppose I am replace this as dx and this as dy. Okay, this is my dx, this is my dy means, here you have to think, that what will be given means one is constant. Okay, one is constant and another will be variables. Okay, so in this case the x1 and x2 will be of functions of y. Okay, will be of functions of y. Both x1 and x2 will be functions of y, whereas y1 and y2 will be constants. Okay, y1 and y2 will be constants. Okay, so they will be fixed. Okay, they will be fixed, so they will be constants. So if you are having see here, you have to understand one thing clearly. So first thing is, you are integrating with respect to x, the limits may be of the functions of y, so you have to substitute those limits. Okay, here after integrating with respect to x. So now you have everything as a function of y, then you will have some integration. After some integration you have to apply the constant limits. Okay, you have to apply constant limits. So my next question is, here you are having like this integral, double integral here y1 to y2, f of x comma y is here, then dy dx is here. Suppose this y is having some limits y1 and y2. No, suppose this y1 and y2 are functions of x means, then you have to do this integration first, then you have to apply the limits which is having the variable x, then then all the variables become x, all the terms will depend on x. Okay, then you can integrate with respect to x, then you can apply the next limit x1 to x2. So these limits may be constants, these limits may be constants. Okay, this is second type. Okay, this is our second type. Okay, this is our second type. In type 3, In type 3 you will have two constants. Okay, you will have two constants. So here x1 x2 y1 y2 are variables. Here you will have x1 x2 constant means y1 y2 will be variable. Okay, variable. If y1 y2 are constant means, okay, then x1 comma x2 will be variables. Okay, second type. Okay, in third type you will have two constants. Okay, both limits of x and y will be the constant. So f of x comma y dx dy. So here you will have x1 and x2. Here you will have y1 and y2. Both these x1 x2 are is constant. Okay, everything is constant. Okay, this is third type. Okay, so this is constant. So when this is the case, then when this is the case, you can integrate anything first. You can first integrate with respect to x, or you can first integrate with respect to y. Nothing will change the result. Okay, so you will have for constant limits, we first integrate with respect to x and then integrate with respect to y, or vice versa. It depends on your wish. Okay, now this is the fundamental idea about double integration or multiple integrals. Okay, so I hope you all understand what are the three types of multiple integrals. Okay, so you have to write all this. Okay, you have to write type 1, type 2 and type 3. Okay, in type 1 here x1 and x2 are functions of y, y1 and y2 are constants. Here x1 x2 are constants. Okay, so just to understand the types, but these types are not going to be asked in examinations like definitions or state what type will be this or what type will be that. Never those questions will be asked. Okay, just for understanding you have to go through this and take a notes of this. Okay, just you have to see the problem and you must be able to identify which type is it. Okay, you have to be able to tell what type the given problem belongs to. Okay, so next thing we are going to see some problems under each of the above mentioned types. Okay, type 1, type 2 and type 3. So I hope you all understand the problem. Thank you all for watching this video. Thank you all once again.